So this is a little video about weightlessness, and the idea is that in most scenarios, when we will talk about you don't feel your normal weight, you still have a force of gravity. So the bottom line is that weight in general is equal to Fg. So if you're on the earth, you have a force of gravity. All these guys in the video, they have a force of gravity, right? So you can say that this guy, he has a force of gravity, it's acting down. This guy has a force of gravity, it's acting down. So the force of gravity hasn't gone away. So why is it like these ladies in the middle here, they have a force of gravity. Each one of them has a force of gravity acting down. Why do they float in this airplane? Well, if you think about it, the airplane itself has a force of gravity acting down. And in this context, the plane itself starts to take a nosedive. So what I want to emphasize is that while weight is equal to force of gravity, how heavy you feel, and in other words, how heavy you feel is another way of saying your perceived weight, your apparent weight, perceived weight. Perceived weight, apparent weight. All of these things are the normal force. You feel your weight because of the way the ground interacts with you. Generally, so if you look at this elevator picture, if you're in an elevator at rest, this thing right here is supposed to be a bathroom scale. And what we talked about in class, oops, I'm writing class, bathroom scale. What we talked about in class was that your bathroom scale is designed to be used in your bathroom. It's supposed to be in a room that's at rest on the surface of the earth. So when that happens, your force of gravity causes you to push on the bathroom scale, and that bathroom scale is then holds you up by exerting the normal force on you, right? And that normal force is how you feel your weight. So your force of gravity is Fg, but how heavy you feel is your weight. So the feeling you have of your weight, you feel your weight because of the normal force. Then we went to the scenario, what happens if this this elevator is cut? So now you're still standing on the bathroom scale, but now the cable is cut, and now the elevator itself starts to accelerate at a rate of whatever, free fall, right? So it would be at a rate of g. So there is no elevator to supply the support. So you don't have so in this context, your normal force goes to 0. And it's for this reason that you feel weightless. This causes you to feel weightless. Okay, and that's an important distinction. So I summarize it here. If you want to talk about your apparent weight, you're talking about the normal force. If you're talking about the scale reading in newtons, you're talking about the normal force. If a question asks you, what does the scale read? They're asking you for the normal force. Apparent mass is something slightly different. On all of our scales, we have a button that shifts between pounds. And so your scale should shift between pounds and kilograms, right? The thing is, pounds is a force and kilograms is a mass. So it's actually not a fair comparison. Because one is a force and one is a mass, obviously. The other unit you could use to explain this is you could also use newtons. So if we use newtons, that's also a force. And there's a conversion. Like we know the conversion from kilograms to newtons. Let me do this in a different color. We know the conversion from kilograms to newtons on the surface of the earth is just multiply it by 9.8, right? Many of you know the conversion from kilograms to pounds, even though it's not the same type of quantity, it's a mass to the force. There's always a constant, a proportionality. So I think it's like, it's a 2.2 kilograms equals a pound. No, 2.2, you would divide it by 2.2. So it's, if you have, no, that's not right. You would multiply it by, sorry. So what we're saying is if I'm like, for example, if I have a mass of 55 kilograms, that works out to weight of 55 times 2.2. That works out to around 120, is equal to approximately 120, 121, let's say, pounds. Okay. Whereas 155 kilograms works out to 539 newtons. 539 newtons equals 55 kilograms if I'm talking about my weight. So these two numbers here are my weight, either in pounds. That's my weight. But if I'm in this elevator, this second elevator, when the cable breaks, my apparent weight is equal to 0. I feel weightless. So the next video will walk through this problem, A, B, and C. I just wanted to make a quick note to say, just to add on to this video, to say there was a mistake in the original page. I wanted to bring your attention to this. When you think about what your scale reads, and if the question is asking what does the scale read in kilograms or what is the apparent mass of the person, you'd take the normal force and divide it by G. Originally, it had said Fn divided by mass. That was an error. So I fixed it, but if you downloaded the original handout, you should correct it on yours.